Well, hello and welcome to this Herald webinar in association with IES. We're going to talk about how creating a digital twin of buildings can help us to reach zero carbon targets. My name is Kim McAllister. I'll be hosting this webinar today, and I'm delighted to be joined by a panel of experts. First of all, we have Don McLean, who is the Chief Executive and founder of IES. Hello, John.
Hi there.
We also have his Associate Director, Valeria Ferrando. Hi, Valeria.
Hi, everyone. Hi, Kim.
And to give us the client's perspective, we also have John McLean, who's the Senior Project Manager at Glasgow City Council. Hi, John.
Good afternoon.
So I'd like to start with you, Don, if I may, to please explain what is a digital twin?
I'll try and give you a very short version of it because it's quite confusing. The term is somewhat abused. Everything today is a digital twin. People just put that name onto anything. Particularly when we're looking at something like trying to look at decarbonisation, I think we need to take it a little bit more seriously. But I think if I was to do it in the most simplest form, basically what you could think about it is think about a 3D model. People have seen lots of 3D models, up on TV and things like that, where you can fly through a building and so on and so forth. So if you think about that with a database behind it, the database has lots of information about the building and individual rooms and so on and so forth. But the difference to that now is the fact that you have things like artificial intelligence and machine learning. And what they do is that people will maybe take information from sensors. So we use another term like from an internet of an IoT sensor that would be planted round about a building, and you could see what the temperature's like in individual rooms or whether the relative humidity is too high or too low. You could have that kind of information. And people would then use the AI and machine learning to sort of try and look at trends in the information, try and understand what's going on, and tell people maybe how they could make the building more comfortable. So with respect to the built environment, that's probably the way that most people would think of a digital twin to do.
So it sounds like it has wonderful potential in terms of making decisions and helping us become more environmentally friendly, making better decisions. So how can it specifically help with this target for net zero?
Now, that's where what I've just described becomes a little bit less effective, because the trouble is that when you do something like that, people talk about machine learning and AI. What does that mean? Well, you're kind of using mathematical expressions and equations and looking at lots of data and trying to derive trends and things like that out of it. And that's okay in a lot of circumstances. But when you come to the built environment, when you maybe say, I'm going to build a zero energy building, where's the data to help you make the decision about what you do? Or alternatively, if you're looking at an existing building, you say, if I put a heat pump and I put PV in the ceilings and I pin triple glazing, what's that going to do for me? And again, you've got no history, so therefore you can't really do it. This is where our approach is quite unique and different, because what we actually do is we apply physics. So instead of relying on AI and machine learning, which we do for some things, we do it to look at is a sensor still working or not. The physics doesn't have to learn, it knows. So when we say that say, for example, a heater's been put on a room, we can tell the room that that's what's happening, and it can then work out what actually is happening within inside that space. So the physics-based approach allows us to be able to do things much better and much more accurately, and is absolutely essential if we are going to decarbonize properly. So I think that there's a whole variety of ways that people can talk about digital twin in general, but it's what does that digital twin actually do in the path to help us to decarbonize?
That's amazing. Amazing data and insight that can really inform decision making. So tell me a little bit more about IES and the projects that you've worked on and the way that you do this.
So IES have been around for 27 years, and I can say with confidence that we are regarded globally as the leader in building simulation. So if you look around about the major cities around the world, and let's start from the one that we're in at the moment, Glasgow, and you look at all of the kind of the the medium to large buildings that have been built in the last 20 odd years. Normally, those buildings have been done in our software. They've been designed, and looking at building regulations, the building regulations part will be done in our software. So we have a very strong international representation about what we do. And people, we estimate that with the use of our software over the last 20 odd years, that we've probably saved around about 37 power stations being built, which
wow.
is quite a statement. Yes, it is a kind of wow
really
from that side of things. But you know, the thing is that you know that's only part of the journey. Part of the journey is to how can we actually have it that people have got access to the energy they need in an effective way. That you know, it might cost more, it might be you know, in a different kind of form, it might be predominantly electricity or something like that. But the thing is to look at how we decarbonize is a really complex issue that governments and other bodies talk about, but they've got no solution. They don't know what to do. And really what we've been doing over that period is we've been designing our technology for today and the future. So it puts us in a fairly unique position in terms of what we can do with respect to digital twins. And it is exciting, it is challenging. You know, the people we meet and show it to, I've actually just finished a meeting with an organization in Germany, and I was talking about what we can do. Now, this company are well experienced in the construction industry. I was telling what we were doing, and they were just smiling and laughing, just saying, yeah, this is great, this is brilliant, you know, from that kind of thing. But there's a long way to go. The physics-based approach to digital twin, I believe, is absolutely essential for buildings. Yes, we'll use AI, and yes, we'll use machine learning, but really the necessity is to do it with what we call physics intelligence.
That's amazing. Well, Valerie, I'd like to bring you in at this point to tell us a little bit about some of the projects that you've worked on at IES, because I know that we're going to discuss Pollock Park in a minute, but what else have you worked on?
Yes, so thanks, Kim. So we have been helping a number of organizations in Scotland, for example, to build up their roadmap to zero carbon. For example, we have been supporting Orkney Island Council to manage better a portfolio of different types of buildings located in different areas in the islands, in the Orkney Islands, to spot anomalies in their building operation and to identify places where there is a potential savings for energy. All this done collecting their data, but also applying our physics-based digital twin. We have done something similar with Stirling City Council. We are helping them managing a portfolio of 30 schools and identifying where, for example, renewables could operate better, and comparing the generation from PVs, for example, with a model to see where they need to, for example, clean the panels to ensure that they generate what is expected. And also this is saving a lot of time for the facility managers and energy managers of the council to operate the buildings efficiently and solve issues in advance. Also, this work helped them to track the targets and the progress towards zero carbon. So they were monitoring some KPIs, some metrics in terms of energy, water consumption, CO2 emissions, and they were able to report to their upper levels in the Scottish government, for example, on the progress of these 30 schools towards zero carbon. Then we are also helping a number of universities in Scotland to create digital twins of their campuses, for example. So this is a very interesting approach because campuses is a campus, for example, university campus is an ideal scale for starting looking at a roadmap to decarbonization. You start at scale and then you start looking at the interaction between the different buildings, how they can share resources, how they can become more efficient first, for example, replacing windows or carrying out other energy conservation measures. And this helps both the targets, but also the health and well-being of students. Academics can also use the same digital twin for engaging with the students and make them playing with the digital twin. So it's very much engaging, and it's another kind of use of the digital twin itself. So, and then we helped us also some city councils, like Glasgow City Council. We have been working with them in a number of projects, and one of them is Pollock Park, which is the one we are going to talk about. Do you want me to introduce it now?
Yeah, I would love to hear more about it. But before we talk specifically about that, I mean, it sounds like the potential for this is wonderful. So you're now talking about whole campuses rather than just one building. I mean, what do we need to do to scale this, to its full potential?
Yeah, so I think in general, like the concept is that a digital twin can be at any scale. So depending on the information you have, the type of analysis you want to do, and all of these levels of digital twin can all feed back in the same kind of unique federated model. That is something that can grow in scale and can potentially cover even a full country, why not? So you can start from a single building, then extend to number of buildings, and then to communities, cities, and then the country. And depending on the information you have, you can run different analysis or target your analysis to different target audience. So
Wow.
more technical or even more like citizens or occupants of the building, so that they can even change their own behavior and play a role actively in the decarbonization path.
That's amazing. What fabulous technology, and really exciting to hear, especially from Dawn, that, Scotland's leading in this, and we're speaking to countries across Europe and I guess potentially around the world as well. So John, you've joined us from Glasgow City Council, and we're going to hear about this specific project in Pollock Park, which is one of my favourite parks and wins prizes all over the place. Could you tell us what the problem was first, and then we can hear more about the solution? So what did you want to achieve with this?
Well, initially the connection with IES was based on the work that's being done to refurbish the Borough project, which is nearing completion and is due to open in March next year. But we quickly realised that we could actually roll out right across Pollock Country Park. And that would then include specifically Pollock House and what potential we could get from the currently derelict courtyard building. And that's allowed us to develop a proposal within the courtyard building so that possibly we can bring back the Clydesdale horses. And that then brings in a connection that the Clydesdale horses were originally where the terminology horsepower came from.
Wow.
So there's a link with energy right through. And that's allowed us to go ahead, and we're going to install generators in the sawmill so we generate electricity from the river. We're also going to install, just about to install, one of the biggest, if not the biggest, battery in the borough, so that the borough will be able to run virtually off-grid for periods of time. So the intention is to try and achieve a country park, that would be a microcosm of the city that could be self-sustainable regarding energy and help with the carbon side of it. But we're also trying to take that a wee bit further, working with IES to say, well, we could put a display into the refurbished courtyard, which would allow people to interact with this. So it's not just about ourselves interacting to get better outcomes of any of these ideas that we have, but the public can then interact. Now, I'll give you one very simple example. If you were just to change one light bulb in your house, the old traditional light bulbs were maybe 50, 60, 100 watts. Well, LED lighting now is down at 3, 4, 5 watts. You save substantially. Now, roll that out right across a building, right across a country park, or indeed a city, and we could make substantial savings by doing very small things. So it's a massive potential.
A huge opportunity, and in a park where people are always there and can really engage with it. So Valeria, to come back to you, what was your role in this? What did IES give to this project?
Yes, basically we proposed the use of a digital twin to support this, like scenario analysis towards this, bringing the park off grid, or at least to try and achieve like zero carbon targets by 2030. So we used our digital twinning technology to create first a model of the park at park level, so considering like also the greeneries and everything. And then in the park, there are three main buildings, as John said. So the barrel, of course, where IES was already working on making analysis on the retrofitting options. So this is what was a part of it. Then there is Polo House, which is like an historical building, so presenting challenges in terms of like what you can do there, because you cannot go and do certain types of interventions like installing PVs on the roof. It's something which is not going to work, of course.
No.
And we don't want to do. So Polo House, and then the courtyard. So this currently not used building to be totally demolished and rebuilt. And we kind of created specific digital twins, more detailed, of these three buildings, and started to analyze different potential interventions, taking into account what was already planned by Glasgow City Council, and also suggesting perhaps other ways to implement this and make these renovations and overall energy balance more efficient. So, for example, the whole of the courtyard was really quite important, because it was the one that at park level had the highest potential for savings, due to the fact that we could do more things, being starting from zero. And interestingly, there, like the use of water was really something like we explored a lot. So, for example, we explored the installation of a water source heat pump to provide heating to the building, and also the use of the installation of an hydroelectric turbine, which can bring really a huge amount of savings to the building once it's built. And so the water was really the key here. And also the other strategies that we analyzed was to how these different buildings could be like factored together to achieve altogether a positive balance, or at least a nearly zero energy balance. So exploring even PVs in the park side, and we were also simulating, for example, a combined heat and power generation to be installed at the barrel, and also to serve other areas. So different options, and we provided like a set of results for different scenarios towards 2030. And despite like the analysis were really technical and really deep, we tried to provide an easy way to access this through dashboards. So through something which is easy to understand, both for technical people, but also to citizens. So we had this like interactive dashboards with data coming live from our simulated scenarios, all showing the different type of intervention proposed and what was the impact on the final energy and carbon footprint. And this was done for technical people, but also for citizens. So trying to convert complex metrics into something that people could understand. So, for example, if I save X amount of energy, this corresponds to Y number of houses in Scotland. So people can just understand what's the impact of different interventions.
That's fantastic. So, Dawn, you've kind of got the overview of all of this. How does this sort of further the ambition for using this digital twin technology when it comes to decarbonisation?
Well, I think the thing is that we're looking at this, to some extent, as Lydia said, this is a kind of a good example. It's a small kind of campus type of thing. And that's kind of the sweet spots for it. The thing is that to look at this seriously over the next 30 years, what needs to be done, we will fail, right? Unless this kind of technology gets embedded fully, we will fail, because we can't save the planet with spreadsheets. We can't save it with simple kind of approaches from that side of things. And that's the serious matter we need to consider. And we are moving towards failure at this moment in time. We're not doing what we need to do. So it's a serious situation. And our company culture is such that we feel that we've got a responsibility, because we have the technology, we have the way of doing it. We need to get it deepen as far into the market as we possibly can. And some of the things that Valeria said, we've been able to do for a long time, but some of the other things that we're providing people with, like what we're doing with Stirling and others, is that this is an extension to what we do, and something that enables us to do more about decarbonisation. But there's a long way to go, but I am absolutely certain that our technology is absolutely essential, and nobody can do what we can do, right? And I think that's good for Scotland. Scotland likes to talk about innovation. This is pure Scottish innovation. But the thing is that the interest that we're getting now from large companies globally is interesting, because they can see that we are fairly unique. We've got one large company that talk about us as being the best in class. So of all the kind of people that are working in digital twins, they reckon we're the best because of what we can do, the effectiveness of what we can do, and the history and proof of what we can do. I think is all things that give people confidence. But there's a big world out there that we're trying to save, so we've got a lot of work to do.
We do. And if people watching this are intrigued and want to come to Pollok Park and learn more about it, when can they do that? When will it be open to the public? John?
Well, the Burrell itself reopens in March next year. The Pollok House is currently open and fully operational. We're doing a variety of projects right across the park. We have a bid in with the Levelling Up Fund to undertake the work at the courtyard, and hopefully we'll hear a positive result in the autumn from the government to fund that, and that would bring the Clydesdale horses back to the park. There's no reason not to visit the park now. It's a beautiful country park, and is one of the treasures of the city, if not the country.
Well, this has been fascinating. Thank you all very much for joining us, and I'm sure the Herald will cover the story as it develops. But for now, I'd just like to thank the Chief Executive, Don McLean, Valeria, you're the Associate Director, and also John from Glasgow City Council. Thank you very much.
Thank you.
Thank you.
Thank you.